Algebra 2, Chapter 3.3, Exercise 1 through 7. This is the section where we fit data doing some quadratic function modeling. I'm going to do the odd number problems here, and not all of number 7, but 1, 3, 5, and then part of number 7. 1. Find an approximate quadratic model for the data by estimating the coordinates of the vertex and one other point, then sketch the graph of the model. Well, here we have a lot of points on the right side of the parabola, but only looks like one on the left. So we're coming up here from the right, and it looks like maybe about right here would be an estimate of the vertex. And for that, we have the point 4, 8.5. And then as far as one other point, we have this other one down here at 8, 2. So using the standard form, which is f of x equals a times quantity x minus h squared plus k, we're going to substitute in what we have. Well, we know what a vertex is here, 4, 8.5. And we know what h is, we know what k is, we don't know what a is. So I'm going to write out with these points first and put f of x using the vertex, a times quantity x minus h, and in this case h is equal to 4 and k is equal to 8.5. So we have x minus h, which is x minus 4 squared, plus k, which is 8.5. And now we're going to substitute in this other point, 8, 2. So I'm going to take this data here, and we have 2 is equal to a, which we do not yet know, times x, and x is 8. We have 8 minus 4 squared plus 8.5. And now we can just go about solving here, subtracting 8.5. We have, and then also, so that'll cancel, and then we have 8 minus 4 is 4, and 4 squared is 16. So we have on the left side 2 minus 8.5, which is negative 6.5, equals 16a. So a is going to equal negative 6.5 over 16. And we can go to our calculator. So I'm going to get out of this mode. Negative 16, negative 6.5 over 16. And for that, we get negative 0.40625. So we'll go to 3 decimal places, 406, and we'll say approximately equal to negative 0.406. And so our equation is going to be f of x equals negative 0.406 times quantity x minus 4 squared plus 8.5. So that's going to be our approximate quadratic model. That's what this is. We'll box this in. And it says, then sketch a graph of the model. So here's the vertex, here's the other point. So we can just go in just a sketch like this. You can kind of sketch it freehand. And I'm just going to hit the points pretty much. Hit this exactly. So it'll look something like this. And on the left side, it'll go something like this. And symmetry. That looks something like this. And then we have our axis symmetry, which is x is equal to 4. So that's going to be problem number 1. Let's go look at the next other problem, which is 3. Find approximate quadratic model for the data by estimating the x-intercepts in one other point, then sketch a graph of the model. Well, here, x-intercepts looks like if we follow here, we're going to come something like this. And I'm outlining here in this dashed line. So I'm thinking here we're going to get like 1.7. So I'm going to put x-intercept. We're going to have 1.7, 0, and what does this look like? About 9.2, 0. So those are x-intercepts. And then one other point. Now the other point we can use is maybe this one here, 5, 8, which is near the top. So point 5, 8. Now, writing out an equation, if we use the factored form, since we have the x-intercepts, we're going to have a, which we're going to have to calculate. So we're going to have quantity x minus 1.7 times quantity x minus 9.2. So that's just using the x-intercepts. And then if we use that one other point, okay, we'll say using the point 5, 8, we have f of x, well that's going to be 8 is equal to a times quantity, we're going to have 5 for x minus 1.7 times quantity 5 minus 9.2. And if we just multiply these things together, and I'm going to just go to my calculator and figure those out. So we'll have 5. So 5 minus 1.7 times quantity 5 minus 9.2, close parentheses, we get negative 13.86. And so A is going to be equal to A divided by, or 8, divided by negative 13.86. And let's go ahead and put this in our calculator. 8 divided by negative 13.86. So negative 0.577 to 3 decimal places. So that's going to be it. So our model, our approximate model, is going to be f of x equals negative 0.577 we have quantity x minus 1.7 and times quantity x minus 9.2. So that's going to be it. And the last thing it asks us to do is what we've pretty much already done, which was sketch a graph of the model. Well, the graph is already pretty much sketched right here. Again, this is a hand-drawn sketch. After this one, we're going to go next and work over some quadratic regressions in our calculator. So that's approximately it. Next on number problem 5, use the quadratic regression feature on the graphing calculator to find the approximate quadratic function model for the data and evaluate exercise 2 found in the table. And so we're taking the same exercise here from 2. So if you do 2 by hand and see how it matches what we do by 5 using our graphing calculator here. So we're going to go to our calculator and use the quadratic regression feature, and it goes right here. We go to Stat, Edit, and we're going to put in our x values, and those ones are going to be 2, 3, 5, 5, 7, 8, 9, and then we go to the other column. Here are corresponding output values. We have 2, 1, 1, 2, 4, 7. We've got to make sure that we're matching here. Looks like we are. So we're going to put in these values here, stat, calc, and we're going to go to 5, quadratic regression. So we're going to go down here, L1, L2 frequency list. Okay, we get down here to store regular equation, and this is where we're going to enter that equation into our function editor in our calculator. To do that, we're going to press alpha, y equals, and then arrow to the right twice. And then we enter where we want the equation to go in place. Well, we have y1 highlighted. Press enter. And so we're going to store the equation that we calculate in y1 in our function editor. Press enter, and enter one last time. And there it is. Let me check my data to be sure. Stat, edit, 2, 3, 5, 7, 8, 9, and 2, 1, 1, 2, 4, 7. Okay, there it is. Looks good. So we go to y equals, and we see the function entered here. Press graph, that's what it looks like. We're going to do a couple things. We're going to change the format to get our grid line on. So we have our grid line. We're going to change the window here from 0 to 10. X max and Y minimum 0. So we should get a better fit here. And the last thing we're going to do is go back to Y equals and put our value right here, plot 1, turn it on. So we're going to see the points and see how this curve matches these points. And we should see that that matches quite well here. So that'll be a good model. And let's go ahead and go to Y equals, so 0.296 x squared. Let's see what else we got. We got a lot of different places. Minus 2.6x Okay, we'll put it in here, 0.296 x squared. And that's going to be minus, let's go back to our calculator. I think it was 2.6 x plus 6.14. Let me see if we forget 6.14. Then sketch the graph with the graph of your model, compare the graphs. We have it right over here. Let's look at that graph another time. See the graph here? So it looks like we have a vertex here between these 2 points. You can just, looks like these first 2 points are hidden pretty good. Here's our 6.14. Here's our vertex right here. And then we're hitting these points on the right. Okay, let's look back here. So it looks like we're about right here. We're hitting 6.14. So we're going something like this. Okay, this will be our vertex about right here. Going underneath this thing right here. And we're hitting these points, these last 2 on the right. So that's a pretty good sketch of what ours look like. Let's look at it one more time. Yeah, that's pretty good. So we'll call this a good modeling right here. Okay, 6, good exercise. 7, the town is holding its annual music festival 6 months from now based on last year's ticket sales and survey results. Study group presents, variable C represents. So what we're going to do is there are several parts to this. This is quite long, and in the interest of, so it's the part A, B, and C is using the quadratic regression feature. And that's the one I'm going to use here, and I just don't want to make the video much longer than it already is. So I'm going to go back to the data and just put it in place here, and here's our data. And for that we go to Stat, Edit. I'm going to clear off the data, clear down, down, clear down, and then we just enter the data. So its profit depends on ticket price. So we're going to have 25, 30, 35, 40, 45. Looks like our ticket price are going up by increments of $5 per ticket, which is really, when you think about it, a real world type problem. So here we have our list on the left, and on the right we have 2, 17. So you can see that we're making more profit based on these increasing ticket prices. 30, 34, and then at 50 we have 26. So now the prices are starting to go down a little. See that? And then we have 21. And finally, at $60 a ticket, we make a profit of 7. That'd be 7. Guess that's thousands of dollars, right? Okay, so we have that. We can go to find out what the equation is. This time I'm going to write it down because it's harder to see when they get it out. So I'm going to go clear this function out here and go to Stat, Calc, Quadratic Regression, down, down, down. Okay, store the equation. I'm going to go to alpha, y equals, and go to the right twice. And this time I'm going to go down to y2 to get, I think, the red function here. Press enter, enter, and then calculate. So we're going to have negative 0.091 okay, plus 7.84x minus 136.7. So here it is. I'm going to write it down here. And this will be part C. I'm going to go over to C here. We'll call it profit equals, C. Negative 0.0907 C squared plus 7.84 C minus 137. That's our approximate model. And then it says, then sketch your graph. You can do that, but first we're going to dimension off correctly. Looks like 0 to 60 on the x-axis and maybe 0 to 40 on the y. So we'll go to, let me go ahead and enter this. It's already in here, right? Okay, yeah, let me go to second, actually, on that, second window. Okay, we'll just go to window. Yeah, we can go to 0 to 60, and we're going by fives, $5 per ticket. For y maximum, we're going to have 40. I think we're going up here we'll go up by 5 also. We have the plot turned on, so we graph. This is what we get. So a pretty good look here. So now the 60. I want to go a little. That'll be pretty good. Looks like we're coming up here, right here. We're hitting that point. So it looks like we're right here. Let's be 5, 10, 15, 20, 25, 30, 35, 40. Between 40 and 45 is where we are at the top right. And right here. Very good. On. Get between 40 and 45. We're about right here. And so we're coming like this. And this is a rough sketch. We're hitting our top about right here. And then we're going down like this. Yeah, it looks something like this. Anyway, quite a bit of analysis here. Good luck on all these other problems. Good luck, and thanks for viewing.